Before we jump into making our own containers, let's talk a little bit about how to clean up containers, sort of as a follow-up to the question about where things live on the file system. I did mention that we can look at our Docker image list. And in fact, there's a shorthand for list, which is just ls. You can do Docker image ls. And this will give us a list of Docker images that we have locally. Now, if we want to delete an image, we don't know where it lives on the file system. It lives in some place that Docker keeps track of. So we have to use a Docker command to do this deletion. And given that Docker image ls is how we see a list of them, it may come as no surprise that the command to delete one is Docker image rm. And when we delete a Docker, the safest way to do this is to find this image ID and to go ahead and just copy it and paste it down here. You can also delete by name, but sometimes you might have multiple versions of the same name, and so it's usually easiest to delete with the image ID. So if we run that, oh no, we get an error. So it says it can't delete this particular image because the image is being used by a stopped container. So what does that mean? Well, let's see if we have a container that might explain this. So we can do Docker container ls, and curiously, there doesn't appear to be a container in our list. So what does it mean that we have an image that is being used by a container, but we don't have that container? Well, the reason we have this going on is because we did run a container and then we finished with it, but we didn't tell Docker to delete the container. And the reason Docker doesn't delete the container is kind of actually comes back to one of the questions during the break, which was, how do if these always get deleted, how do we save our work, or how do we come back to the settings we might have changed or anything like that inside of the container? Well, Docker will stop the container and stop running it, but it doesn't delete all the data that was there when we were running it. And if we want to just see these containers that are stopped but no longer running, we can give the Docker container ls command the flag all. And that suddenly shows a bunch of different containers. We see this Alpine that we ran sh in. I did that a couple times, so there's two different containers for the two different times that I ran the sh command in the Alpine Docker. There's the container that we use to run the cat /etc/os release. There's another instance where I ran the Alpine Docker, and then there's the hello world container that we ran. So all of these containers are still sticking around. They're just now what are called stopped. Stopped containers are, in theory, you can stop a container and then you can restart it. I almost never do that. Some people do that depending on their kind of workflow with Docker containers. That's a little bit more of an advanced topic, so we're not going to get into like stopping and restarting containers right now. Typically, you would start a container, use it, and then be finished with it, in at least the way I typically use Docker. But in theory, they can be restarted. Instead, for now, we're just going to worry about how to clear these containers out. So much like trying to delete an image, we're going to do a similar command, Docker container rm. We're going to grab this container ID. So I'll go ahead and copy this container ID, and then I'll paste it down here. And that should allow us to delete the container. And I can do the same thing for this next one. And if I delete all these, eventually, once there aren't any that depend on this Alpine image, I'd be able to delete the Alpine image. Rather than do that, I'm going to go ahead and delete the container that ran the hello world image that we did at the very beginning. And once I've done that, we should see that those three containers I deleted are no longer part of this list. In particular, there's no container that depends on the hello world image anymore. So I should be able to docker image rm hello world. And this time it should work, and it tells us we've deleted some stuff. So basically what we just did there was we tried to delete an image. It didn't work because there was still a container, a stopped container that was using it. So we deleted the stopped container that depended on the image, and then we were allowed to delete the image. Any questions about that? Or maybe about the difference between containers and images in this case? Okay. There's a command that makes this a little easier. It's called docker container prune. This should give us a warning that says, you're about to delete a bunch of stuff. If you have been using Docker and have your own Docker images and containers running, don't say yes to this. But if you're like me and you've only been running the containers locally, you can go ahead and say yes, and this will just clear out the containers that you're not using. I see a question. Alberto, is it?
Yeah, hi. So I was wondering, I actually already use Docker for certain things, and I was wondering how much of a bad practice is to use certain Docker images as virtual machines. Like, I know that you usually use Docker for a single process, like maybe you will run a pipeline or something like that, but sometimes I want to have like a little extra persistency, like for example, I have some materials for a course and I want to just use that for running my Jupyter notebooks. Is it a good idea?
Yeah, it's actually not a bad idea at all. So in fact, I just had showed you this NeuroPython Docker, which contains this library that I maintain. And in fact, one of the ways I use it is that you can start it up such that it runs a Jupyter Notebook server, and it's already got the NeuroPython library installed inside of it. And a lot of times I will just run analysis code or that kind of thing in a Jupyter instance that is running inside of the NeuroPython Docker. And that way I don't have to worry about, maintaining the installation on my local computer or something like that. So there's really nothing wrong with that. We'll talk a little bit more about, we're quite shortly here, we'll talk about how we could make that environment and run it. And typically, as long as you keep the files you're editing outside of the Docker container, and we'll talk about that as well, it should work fine because they'll just be saved on your local computer. Does that make sense?
Yeah, thank you very much.
Cool. All right. So that's how we clean up containers. Any other questions before we move on? Okay, so the next thing we'll talk about is creating containers. So let's start by just running that Alpine container again. And I'm going to do a couple things. First, I'm going to say I'm going to give that -it to the run, that -it argument to the run command, so that it's interactive. I'm going to add one more option, which is --rm. The --rm is a good one to know about. It basically, what it does is it automatically deletes the container as soon as you're done with it. Rather than that container becoming a stopped container, it'll just get deleted right away. So that'll keep you from having troubles deleting your images later. I'm going to run Alpine, and I'm going to run the sh command. So once again, this should start me up, and now I've got this new hashtag prompt as the kind of root user of this Alpine Docker. So like, let's suppose that I started this up and I want to run Python. So I'll type Python 3. But of course, Python 3 is not found. Okay, well, what do you do when you don't have Python and you're sitting inside of an operating system? Well, one thing we could do is install Python. And in the Alpine operating system, we can install Python with this command, apk add --update Python 3. And I'm also going to just install pip as well, and Python 3 -dev. So apk add --update, and then Python 3 py3 -pip Python 3 -dev. So I can go ahead and run that, and this is just a program that installs the downloads the relevant program files from server and installs them locally on the Linux server. And this is all going to run inside of the Docker. It's basically connecting to the server and downloading those files now and running the installation. And now, if I type Python 3, and I'll just type Python 3 dash version, I get a version because it's been installed inside of the Docker. Okay, so now, however, if I exit out and then I try to Docker run -it-rm alpine Python 3 dash version. So basically, I'm going to try to run that same command in the Alpine Docker image again. I'm going to get an error again. And the reason is that we can't find the Python 3 executable file once again. So the reason that I can't find the Python 3 executable that we just installed is because we installed that in a different container, and then we exited the container, and now we're trying to start a new container with the Docker run command. So in the new container, Python 3 still isn't installed. It's just the plain vanilla Alpine. So to get around this problem, a lot of times what we want to do is we want to build a Docker image that already contains Python. And then when we start it up, we don't have to install it. So to kind of demonstrate how we do this, we're going to go into that. Let's see where I am. So I'm on my desktop. So I'm going to go cd into Docker intro, which is that file we downloaded and unzipped earlier. And there's a couple directories here. I'm going to cd into the basic directory. And in here is a file called Dockerfile. And notice that this Docker file has a capital D. That's the standard for Docker files. And Docker files tell Docker how to create a Docker image. So I'm going to go ahead and open this Docker file up with an editor called Nano. You feel free to use your favorite text editor. That's totally fine. But Nano is included on most operating systems, so it should work for you. I'm going to say Nano Dockerfile, and it contains just a few lines here. The first one is a line that says from, and then a couple lines that say run, and then a line that says command, or CMD. So we'll go through these one at a time. The first basic idea is that we typically build a Docker from an existing Docker image. So if we want to build a new Docker image, we don't want to install the operating system ourselves. We want to start with something like Alpine or Ubuntu. To this from line will typically contain just the name of a Docker image. So this could be nben/neuropython, the Docker that I showed you that I maintain. But in this case, we're instead of using NeuroPython, we're going to use the Alpine Docker. So we'll just say from Alpine. And we can put a tag here. We can say from Alpine latest, or we can put from Alpine version. I'm just going to put from Alpine. That'll use the latest by default. Okay. So now we want to run. We're going to build a Docker out of the Alpine Docker, but we want to make sure that we install Python for this Docker image. So let me delete this. The way we install a package or do something like installing things inside of a Docker image is we use this run command in the Docker file. And all that the run command in a Docker file says is that when you're building the Docker image, after you do everything before this line, run this command as if I had just started the Docker and run it myself. So let me recall what command we used. It was apk, oops. Add -- update Python 3 space py3 - pip space Python 3 - dev. Now, we could have multiple run commands. We could install something else. We could, whoops. We could maybe just run a command that says echo done installing Python. We can have as many of these run commands as we want, and all of them will get run sequentially when the Docker gets built. And then finally, we have this line that says CMD. So the command line basically tells us what command should be run when we start up the Docker container, assuming we don't request another command. Now, we've seen that we can run like docker run alpine sh or docker run alpine cat/etc/os release. We've seen those examples where the user specifies the command to run, but if the user doesn't specify a command, then the Docker image, excuse me, when you start the Docker container, it'll run whatever is included for this command here. So we're just going to use an example command, and I'm going to write it out and then explain why it's written out in this particular way. Okay, so really all that this line is saying is that when there's no command provided, run this command, this ls-color/etc. But it's specified in this kind of strange format. Basically, we put an open bracket, and then we put each word or component of the command as a comma-separated list of strings and quotes. So this is just how Docker likes you to give the command for a command prompt. And there are reasons for that, but we won't go into them right now. Basically, this is how you have to specify your commands. Any questions about that so far? Okay, so I'm going to push Control-O to save this Docker file. And then I'm going to push Control-X to exit out of Nano, just to make sure those changes got saved. I'm going to cat the Docker file. And we can see that the changes are there. So now what we want to do is we want to build this Docker. So basically, we've made a Docker file with instructions on how to build the Docker, but we need to tell Docker to actually build it. So to do that, we use a command docker build, and we need to give it one argument, which tells Docker what to name this Docker image. So we'll call this, I'm going to call it nben/alpine Linux, excuse me, Python. And I put nben/alpine Python here because nben is my Docker Hub username, but you don't have to use that. You can use nben. It's totally fine. You don't have to be me to use the nben username in your local Dockers on your computer. It will only matter if you try to upload it to Docker Hub. But basically, we're going to say build, name this Docker we're building nben/alpine-python, and then we're going to say dot. And the dot just stands for the current directory we're in. It needs to be the directory that contains the Docker file. When I push enter here, we should get a bunch of information about the process of installing all this stuff inside the Docker. Here right now, it's running this apk add update python 3 etc. command. This will take just a few seconds, like it did when we actually ran it inside of the Docker container a minute ago. Now it's going to run that echo command, and now it's basically finished, and it's saving up the Docker image. And okay, so I believe if we say Docker image ls, we should now see nben/alpine Python as one of our Docker images. This is a Docker image we didn't pull from Docker Hub. It's one we actually just built ourselves. So if I now say docker run, and I'll do docker run -it --rm nben/alpine Python, what do people think is going to happen? Anyone want to volunteer a guess? So
it's gonna echo the command in the Docker file.
so it is yeah, so it's gonna run this command. So it'll run the ls -- color / etc command inside of the Docker container. So let's see what that looks like. Of course, it takes a second to start it up, but there we have it. There's the contents of the etc directory inside of our Docker container. Let's do that again. Docker run -it -rm and ben /alpine python. And this time I'll go ahead and run the sh command. So again, we put a command, a default command in that Docker file, but we didn't the command doesn't mean we can't put our own commands in instead. So I'll go ahead and run this sh. And here I am inside of the Docker again, the Docker container. But this time, if I type Python 3, it's already installed because we installed this this Python executable in Docker earlier when it built. Yeah. Okay, so I'll go ahead and exit. Okay, now just a couple notes. I'm going to cat that Docker file again. This command we used here to install the Python. This APK command I think is specific to Alpine. If we were doing this on Ubuntu, for example, we would have wanted to run apt-get install Python 3 py3-pip, etc. And the particular command that you use for installing software libraries and programs and such is going to be specific to the operating system you're using for your Docker image. But for every Docker image, the operating system installed inside of it is equivalent to the actual operating system. So if you're having trouble getting things installed inside of an Ubuntu Docker image, you can go ahead and Google Ubuntu help, and usually that will help you figure out what's going wrong. If you are on a Debian, you would also use that apt-get command. Just type it back out, apt-get. If you were on CentOS or Red Hat, you'd use yum. It just kind of depends on the operating system. And let's go back into that nano file just real quick. Sorry, into that Docker file, just to kind of talk through a couple more things. So it's pretty common to have this first run command install some operating system level tools like Python, and then to have a second run command that says, for example, pip install, and then some library. I'm going to install PyTorch. Typically you'll have lots of run commands, and Docker will always run them in order. And let's suppose that I did something like this. I said pip3 install PyTorch as the second line. Now, just FYI, PyTorch is not the name of the library, and this will fail. So I just want to show you what that looks like. I'll write out that Docker file, and then I'll push Control X to exit. So now I'm going to build, and we'll call this mbed/alpine python : and I'll give it a tag, bad build, because this should fail, I think. But otherwise, same command. We'll go ahead and build a new image. And what's going to happen is it's going to it actually already ran that apk add update command, and now it's running the pip3 install PyTorch command. And I think, okay, my mistake. The library is called PyTorch. I thought it was actually called Torch. No, never mind. It did fail. So yeah, and here's the exception. You tried to install PyTorch. It's actually named Torch. So we got this big error, and this is actually the exact same error we would have gotten had we tried to do this in Ubuntu. But a lot of times it can be very frustrating to try to debug an error by changing the Docker file and then rebuilding it, and then changing the Docker file and then rebuilding it until you figure it out. So a kind of tip about what you can do here is we can go back to the Docker file. I'll come down here and I will just comment out these last couple lines because we know that the error happened here, right? So if I comment out this line, and you can comment lines with a hashtag, kind of like in Python, it won't run this line and it won't run this line. And so it'll stop after the last command that worked. So I'll write that out. I'll exit and we'll go ahead and build that again. This time it should be pretty fast. Yeah. All right, so we've built it. We can see that new Docker Alpine with the tag bad build in our Docker image list. And what I'm going to do now is I'm going to run it again with that interactive and automatically remove the Docker container options. I'm going to run nben/alpine python :bad build. And I'm just going to start up a shell once again. And I know that the command that failed was pip3 install PyTorch. And if I run it here, it's going to fail again because it's exactly the same thing as when it tried to build the Docker file. It'll give us the same error message. But at least now I'm here in the terminal where I can just try that command again. Like, okay, maybe it's not called PyTorch, it's called torch. And I can run it again, and this time it'll work. And so now I can go back to the Docker file and put the correct command in. So this is just to basically say that if you're having trouble getting the installation or the build stage of a Docker container to work correctly, you can comment out the lines that are breaking and then enter the Docker using the shell and try to debug it yourself inside of the Docker image. Is that how you would want to do that, everyone? Okay. Any questions so far? All right, I'm actually going to cancel this because we don't want to wait through the rather long installation of PyTorch. Okay, so that's the kind of basics of how you install things in a Docker. Now, one thing I'll just mention this: if you have a professional Docker Hub account, there's actually a very easy way to push a Docker image. You literally can just say Docker image and then push and then the image name. Now I'm going to go ahead and get our list of images again. Oops, I am still inside of the Docker container, so that didn't work because the Docker container doesn't have Docker installed inside of it. So I need to exit out of that first. Let me go ahead and get a list of the Docker images. So if I wanted to publish this to Docker Hub, this latest version, the command I would need to run is docker push, and then I would just give the name of the particular image I want to push. And no, I'm not actually sure if this works. Okay, it is going to work. You have to be logged into Docker Hub through the Docker server if you want to do this, and you can do that from that little icon of the whale that we looked at. There's also a command docker login if you have a Docker Hub username. However, this method of publishing Dockers is not as useful as it used to be because Docker Hub is no longer free. So you have to pay for a professional account for these to stick around for very long. But once this command is finished, there'll be a page for the Alpine Python Docker, just like there's a page for this NeuroPython Docker image. Any questions about that? Okay. One more thing we should just mention, and that's that you can rename a Docker image that you've already built. So we made this nben Alpine Python Docker. But maybe I think that name's not very good, so I just want to rename it. So if you want to do that, the command is docker tag. And basically you could say docker tag nben/alpine python :latest, and I want to rename it, retag it nben/ I don't know, Alpine Python 1.0. And then if we look at the list of Docker images, we'll see that there's now a Docker image 1.0 as well as a Docker image latest. But that said, they have the same container or image ID, so they're actually identical. They're just one has a different tag now, and now I could push version 1.0 if I wanted to Docker. Okay, any questions so far? All right. All right, so let's look at a slightly more practical example of how this might be used. For this, I'm going to cd space dot dot to get out of this basic directory. So we're now in just the desktop / Docker intro directory. And I'm going to switch directory into the sum directory. So again, I'm in the desktop Docker intro / sum directory. Now in this Docker, in this directory is a Docker file and a Python file sum.py. If we just look at what's in sum.py, it's a very simple little, it's just a very simple little program that takes whatever numbers you give on the command line, turns them in integers, and adds them up and prints out the sum. So just to demonstrate, I can just run sum.py 10, 11, 12, and it prints out the sum is equal to 33. So it's a very simple little Python program, but we're just going to use this as an example of some other Python program you've maybe written that's part of your research and that you want for other researchers to use. One thought might be, well, we've got sum.py here, and we've got an Alpine Linux Docker image that we just installed Python into. Let's just run sum.py inside of that Docker image. So I can say docker run -it space --rm. And in case you haven't realized it yet, these two options that we mentioned earlier get used all the time. Almost every time I run a Docker container, I want to add these on because I usually want to interact with it if possible, and I usually want it to clean itself up. But anyway, we'll go ahead and run that nben /alpine python Docker. We'll use the 1.0 tag that we just made. And the command I want to run is just python 3 space sum.py to run this sum.py Python file. And I'll give it some numbers. So when I run this, okay, we get an error. Can't open file sum.py. No such file or directory. Does anyone want to take a guess as to why that happened?
Because the file is local and not on the Docker.
Exactly. So this sum.py file is here in my current directory, but when the Docker was running, it only has access to files that are inside of the Docker container. So if we want to be able to use this sum.py file, we're going to need to find a way to put it inside of the Docker container. So there's a couple of ways to do this, actually. The first one is that when you start up a Docker container, you're allowed to take pieces of your file system and sort of clone them inside of the Docker container. So just to give an example of how this would work, I can say docker run. Once again, I'm going to put these -it and -rm options, but then I'm going to put a new option, which is -v. -v stands for volume. Volume is, in case you haven't heard the term volume used to refer to like file systems, a volume typically just refers to some directory or directory structure or file system that contains files and directories and such. So when we often talk about mounting a volume inside of like an operating system, or when you want to mount a network drive from someone else's computer, you're mounting a volume over the network. All that really means is you're giving your local operating system access to that other volume. And that's what the command, the option here does in the Docker run command. It's going to give the Docker container access to some directory on our local computer. So what I'm going to do is I'm going to say $pwd, and then I'm going to give a colon, and then I'm going to say /temp. Now, $pwd stands for whatever directory you're currently in the shell. So for me, it's this directory /user/embed/desktop docker intro some. If, by the way, if you're on Windows, this may not work, and you may need to, instead of pwd, you may need to use %cd, like that. Try it with the pwd first, but if it doesn't work, try %cd. Sorry?
When I write pwd, it outputs the path. I don't know if that works.
Let me. If you type pwd like this, it will output the path because that's a Linux command. Also, if you type echo pwd, it should do the same thing. But if for the Docker command that we typed out, just make sure it's in capitals for the command. So what this is telling Docker to do is to take this directory on my local computer and clone it as /temp inside of the Docker container when it runs. So now I'm going to say nben/alpine python :1.0, because that's the name of the Docker image we want to run. And then I'm going to say python 3 /temp/sum.py, because inside of the Docker container, this sum.py file will be in the /temp directory. And then I'm going to give it some arguments, 10, 11, 12. Hopefully this will give us back an actual sum. Yeah, so this time it worked. So using this volume option is one way we can get files that are in our local file system inside of the Docker container for when we run things. And I just want to be very clear that this isn't copying things. This is actually giving the Docker a view of the file system. So if the Docker container then edits the files on your file system will be changed by the Docker container. It's not keeping track of things in a separate partition or anything. It's literally editing the files on your computer when you use this. One other thing about this option is that you can have multiple -v options back to back. So if you need to take many different directories or many different files and put them inside of the Docker container, you can do it by just having multiple -v options. Any questions about that? Volumes are often one of the most complicated things about Docker, so if you have questions, please ask. They can be a little tricky at times. Okay. Well, if not, let's look at a slightly different way to put the sum.py inside the volume or inside the Docker. Obviously, this way works great if what we want is just a Docker that has Python inside of it. But if we actually want a Docker that runs this sum script specifically, we want to put that sum inside of the Docker image so that we don't need to put it inside of the Docker container when we run the Docker container. So I'll go ahead and open up that Docker file again. Now here we this is a different Docker file because I switched directory. So let me just go ahead and recreate what we had from Alpine. I believe, actually, let me just copy it. I'm going to copy /basic/Docker file. This is the Docker file we originally edited a few minutes ago. And I'm just going to copy it to this Docker file. So now when I cat Docker file, we see the commands that we did before from Alpine, et cetera, et cetera, et cetera. So I'm going to open up this Docker file. I am going to delete this line because we don't really need this anymore. Also going to delete this line because we don't need it anymore. All right. So the first line is still to install Python because we still need Python installed inside of this Docker. But now what we want to do is we want to get that sum.py file inside of our Docker image. So to do that, we use a command, a Docker file command called copy. And we just give it a file that's in the directory that we're building the Docker in, like sum.py, which is in this directory. And then we tell it where we want to put sum.py. So I'll just put it in /home/sum.py, for example. Now, in addition, we kind of like for our default command to run sum.py. So we can change this default command to be Python 3 instead of ls. And then we can have the second argument, or the first argument to the Python command be /home/sum.py. And then we'll go ahead and give it a couple numbers to add. So I'll go ahead and write that out. And I'll go ahead and exit. I just want to cat that again so we can see it while we're talking about this. And now I'm going to run that Docker build command we used earlier. Docker build -t. And I'm going to call this Docker image Alpine sum, since we're using it to sum things. And we're building it out of the current directory, so I can put a dot. You could also put $pwd here if you wanted, but dot works just as well. But I'll go ahead and build now. And we see this is all going to go pretty quickly. We see there's a line here that says that we copied sum.py into home/sum.py, so that seems to have worked. Now we can go ahead and Docker run -it -rm nben/alpine sum, and hopefully it prints out a sum for us. Since we didn't give it a command, it will automatically run that Python 3 command. Yeah, question.
Sorry, yeah. I was looking at this. Why do you send the PWD as a parameter in the build?
You don't need to. I was just kind of explaining that the PWD variable stands for your current directory, and the dot also stands for your current directory. So it's just that, using either one is equivalent. So there's no
yeah. Is it using it to build the Docker from the folder?
Yes. Yeah. So you have to tell it which folder has your Docker file in it. And there's actually some fancy stuff that goes on behind the scenes with Docker because of permissions and security issues, where you can't, when you build the Docker can't see anything that's not in this directory. So if you try to like copy files from / or from somewhere else in your home directory, it won't work because it's a security violation. So you have to copy the files you want to build into the Docker into the directory that you build the Docker from as well.
For example, if you wanted to do like so it will be like a bad idea to have multiple Docker files with different names in the same folder. It's better to have only one folder for every, like only one Docker file for each folder. Okay.
Yeah, and in fact, you can't. You typically always name your Docker files Docker file with a capital D, just like this. I'm not even sure if Docker will build a Docker file that's not called exactly this. So you can't. I don't think you can have multiple Docker files in the same directory. You need to set up different directories for each one.
All right, thank you very much. And one last question.
Sure.
So when you hit this thing, the path of, so in this case, are we going to have like the sum file inside the same file as the Docker file, so it can detect it?
Yeah, so the sum file will be inside of the Docker image. And just to kind of show you what I mean by that, we can just start up the, we can just run nben/alpine sum, and we can start it up with the sh command. And then, whoops, did I misspell that? Alpine sum. I think because I canceled the last build, it deleted my Docker tag.
You
the run
had
trial.
the run word twice.
Oh, you're right. You're right. I put run twice. Yep. Thank you for catching that. Okay, so if we just start up this Docker container with the sh command, we can look at /home and see that the sum.py file is there, and we can see that it's the same file we looked at. However, just to emphasize, if I were now to let's suppose I hope that Nano is installed inside of this Docker image, but let's suppose I changed this. Okay, Nano is not installed inside of this Docker container, but let's suppose that I changed the contents of this file. This is just a command that will overwrite the contents of sum.py with test, the string test. So now if we look at sum.py, it doesn't contain that script anymore. If I now exit out and look at the sum.py out here, it's still the same. And it didn't change because when you use the copy command to put something inside of the Docker during the build, it's not a reference, it's an actual copy. If you use the -v option to mount part of your file system inside the Docker, it is a reference, it's not a copy. So when you change things that are mounted with -v, you will change the original files. Does that make sense to everyone? Okay. Great. Let's look at another aspect of these commands. So I'm going to open up our Docker file again. So notice that I had to put this 10, 11, 12 here. And that means that when we run this Alpine Sum Docker image without any additional arguments, it automatically runs Python 3 sum.py 10, 11, 12. But really, we want the user to supply these arguments. We don't want these 10, 11, 12 to be part of the arguments that are passed to the command. We want the user to pass them. So what we can do is, instead of using the commands, we can use a different command or a different Docker file command called entry point. And we'll use basically the same syntax. We say Python 3 /home/sum.py. Oops. But we'll just finish it there. We're not going to give those arguments to the container. So I'm going to save this by writing it out, and then I'm going to push Control X to exit, and I'm going to rebuild the Docker. And I'm just going to write over the old Docker for now. I'll name the new Docker the same thing as the old Docker image. I'm going to build it from here. This should take just a second. Now, the difference between command and entry point is that entry point will take whatever, it's sort of like exactly the thing that gets run when you run the Docker run command, whereas command is optionally what gets run if the user doesn't provide something to run. So I'll go ahead and do docker run -it-rm and give the name of the Alpine Sum Docker. With the command, if I had put 10, 11, 12 here, it would have been kind of like if I had put sh here. Docker would have tried to run the command 10 with the arguments 11 and 12. With the entry point, instead what it does is it runs whatever command we put into the entry point, and it provides these as additional arguments to it. So when we run this, we should see that we get a sum of 33, but now if we add another number, we'll get a sum of 46, because it's actually reading these arguments and passing them along to our script. Oops. Does that make sense? Anyone have any questions about that? Yeah.
I think it's me. I don't know. Alberto's hand is still raised, maybe from earlier. Can you still do the entry point along with sh, for example, in some way?
That is a great question. So if you have an entry point and you do docker run -it-rm, and you do something like sh, it's going to give us an error because it's going to pass that sh to the script and it's going to say that's not an integer. So if you want to do this, what you have to do is you actually have to provide another option, which is -- entry point, and that will just override the entry point. So we can say our entry point is sh, and we want to run the Alpine sum, and then it will ignore the entry point we put in the Docker file and just run the sh command here. And so here we can like look at our home/sum.py, for example. Yeah, but that's a great question.
Does it work the other way around? So kind of to override your command if as it was before we changed it to entry point?
You know, I don't know the answer to that because I've never tried to do it. But my guess is that it does work. Let's just try. And I'm going to do this in a very specific way because of something I haven't told you about commands I was going to get to next. But I want to see what this does. So the command, the basic idea here. Okay, so I don't know. I'm not sure that you can do that with command. I think because command is a little bit special, and hopefully what I explain here in just a second here will help make that make sense. I just want to check, Alberto, do you have a question, or is your hand just still raised from earlier? I'm assuming that's a raise from earlier. So let's go look at our Docker file again. Now I'm going to delete this line, the command line that is. We have an entry point, so we don't need that command line. But the command is kind of special. What the command means is if you don't provide any arguments to the Docker run command after the name of the Docker image, whatever you put in command will get put there instead. So it doesn't need to be an actual command. It can be like 10, 11, 12. And now when we build and run the Docker, and if we run it without any arguments, it'll run Python 3 home/sum.py 10, 11, 12. So really the command list here gets added on to the end of the entry point list if the user doesn't provide any arguments at the end of the Docker run command. So let me just demonstrate this. I'm just going to save this out again, push Control X to exit, Docker build -t and then /alpine sum dot. So this will take just a second to build. And then if I Docker run -t-rm, then /alpine sum, I can run this without any arguments, and it will sum up 10, 11, and 12 because those arguments were part of the command. Or if instead I say 1, 2, 3 here, I've provided arguments for the Docker run command, and so it's going to ignore that command line in the Docker file, and it'll just sum up 1, 2, and 3 and give us back 6. Does that make sense? So there's a kind of tricky thing going on there, but let me cat the Docker file. But yes, so the command really represents whatever goes at the end of this run line. And so earlier we had Python 3 sum.py and etc. in the command, and that worked because when we didn't provide a command, it was equivalent to us writing out Python 3 sum.py, etc. But since we provided these arguments at the end, it just ignores the command and adds them to the end of the entry point. Okay, we're coming up right at the end of the time, and we've made it through most of the material that I wanted to get through. There's a lot more to Docker, and there's a lot that you can find in that website that I posted into the Slack. Just real quick, since well, first of all, let me just ask one more time if there's any questions about anything we've talked about today or about how you might use Docker in your own work. I'd be happy to answer those first.
I would be happy to know more about how to build a package. So here we have an example with a script, but I guess when you want to really test for the installation of your package or provide that package through a Docker image.
Yeah, that's a great question.
I'm sorry if it's out of the scope of the lecture.
Not at all. In fact, I was hoping to talk about that next if things had gone a little faster, but we didn't get through everything. That's okay. So a really common strategy is that you've got your package in GitHub, and what you can do is you can let me just open up a Docker file to kind of give you an example. So you've got this run command where we install Python and we copy some files around. We might then apk add update git, and then we could run git clone, and for me, maybe I'm cloning my NeuroPython library. And a lot of times the way people will do this is they'll say git clone, and then we can put a slash at the end of this line to say that the line continues in the next line. This is just for readability. And we can say and, in case anyone's not familiar, these double ampersands in shell means only run the command after the double ampersand if the command before it succeeded. So this says if this git clone succeeds, we're going to copy, or not copy, sorry. We're going to cd space NeuroPython, and then we're going to Python 3 setup.py, oops, install. So this would clone the repository, go into that directory, and then run the setup script that was associated with that repository. And so that for example, in the Docker file for my NeuroPython library, this is pretty much how it does it. And it'll just, inside of the Docker while it's being built, it clones the whole repository and installs it, and then it's installed in that instance or in that Docker image. Does that answer your question?
Absolutely. Thank you so much. May I ask another question?
Sure.
Thank you. So here we have Alpine, but what if you had more dependencies? Like, let's say you wanted PostgreSQL or NeuroDocker, maybe?
Yeah. So my recommendation, if you have a complicated dependency like PostgreSQL, for example, is to find a Docker instead of Alpine that already has it installed. It will save you a ton of time and trouble. Getting some of these things installed is hard, and getting them installed in Docker is getting them installed inside of a Docker is sometimes easier, but not always. But if someone else has already done the work for you, I would absolutely say use the Docker that already has Postgres installed, and install Python yourself, because that's a lot easier than installing Postgres from a Docker that has Python included.
Just a small thing there. Sorry to the thing. When you're going to use like that databases or processes that have to keep running in the background, it's better to use Docker Composer, because it's a bit difficult to have two processes running at once, because there was this one time I wanted to do a website with Docker with Docker, and I had Postgres and the local host in the same site, and I couldn't simply run it. So in the end, I looked it up, and you have to like have two Dockers at the same time. One is going to do Postgres, and one is going to do the local host with the website, and most of the time it's going to work like that.
Yeah, so Docker Compose, there's actually a module in the link I put with the lesson materials about Docker Compose. Docker Compose is kind of its whole thing, and it's a little bit complicated just by itself. But it's made to kind of make the process of starting and stopping and running Dockers a little simpler. And in fact, this is a good segue to the thing I mentioned earlier, which is, let me see, where am I here? Okay, so I'm just going to clone the NeuroHackademy curriculum. And I'm going to go into the directory that I mentioned earlier, which contains the materials that we've kind of been going over this lesson. And I mentioned that it's actually quite easy to build these using Docker. So I'm going to go into that curriculum directory. In here, there is a Docker tutorial directory. And in here, you can see there's a bunch of stuff, including a docker compose.yaml file. This is a file that tells Docker Compose what to do, and we didn't get to talking about these files, but when you see one of these, it's usually a sign that you can use the Docker Compose command, and the simplest version of that is just Docker Compose up, and that basically tells Docker to read in this Docker Compose file, which has a bunch of instructions for how to start and stop various containers, and how to build them and stuff, and it'll kind of do all of the Docker stuff for you, including building the container, starting it, running it, all that. And this is just going to build what's called a Jekyll web server. It will take a few minutes, unfortunately. So if you have to go, I know we're at the end of time, that's totally understandable. But this will build up a web server and start it running. And then I'll be able to go in my web browser to localhost :4000, which is just the port it's running on, and see the material from the course. But of course, the material from the course is also on that website I posted in Slack, so you don't have to do it this way. It's just kind of an example of how you can. Docker Compose is usually used for orchestrating many containers that have to run simultaneously. And if you're interested in doing that, I would suggest looking at that Docker Compose section of the website.